So hello everybody. Today I'll be going through the SMC Senior Math Challenge 2019 question 25. In that question we're asked, what is the area of square A, where the circles C1 and C2 have radius 1 and the centre of each circle lies on the other. So here I've drawn a few coordinate points where Q and S are the centres of both circles. QX is the radius 1, and P and R are the sides, opposite sides of the circle of the square, and V is the centre point. So this is where we start, where we know that QS is equal to 1 as the radius, right? So where QP and RS are equal to K1, K subbase 1, and XR is K2. Now, the fact that it's K2 is going to be really important because it's half the side length of the square. It is also equivalent to PV and VR simultaneously because, as I said, V is the center of the square A, as you can see right here. Since A is a square, PR is 2k squared, is 2k2. Not 2k squared, just 2k2. And QS is QP plus PR plus RS, which is K1 plus 2k2 plus K1 again. So this is where we can see clearly that QS is equal to 2k1 plus 2k2, which is equal to 1. As we can factorize 2 from the equation, we can let k1 plus k2 is equal to 1/2. And because QV is half of QS, QS is already equal to 1, so QV is already 1/2. Now, we're trying to set up something really funny here, so let me cook for a minute. QR is equal to QV plus RV, and as a result, RV, as I already said, is K2, and QV is 1/2. So the sum of that would be 1/2 plus K2. RV is equal to XR and is equal to K2. And then we apply the Pythagorean theorem, where QX plus QX squared is equal to QR squared plus XR squared. QX is already equal to 1, so QX squared is already equal to 1 squared, which is equal to 1 anyways. So 1, as you can already tell, 1 is equal to the, in brackets, K2 plus 1/2 all squared plus K squared. We factorize equivalently to get K2 squared plus K2 plus 1/4 plus K2 squared is equal to 1. We subtract 1 from both sides to get 2k squared plus k2 minus 3/4 is equal to 0, and multiply by 4 respectively. And when we multiply by 4 respectively, we get 8k2 squared plus 4k2 minus 3 is equal to 0. We use the quadratic formula to find k2, which is equal to negative 4 plus minus the square root of 16 plus 96 all over 16, and we can get minus 4 plus minus 112, where we can easily see that 112 is equal to root 16 times 7, and root 16 times root 7 is equal to 4 root 7, and here we can already see that minus 4 plus 4 root 7 over 16, and we can divide that by 4 to get minus 1 plus minus root 7 over 4. So here we get, I already said K2 is equal to minus 1 plus minus 1 root 7 over 4. But since K2 is in positive measurements, K2 cannot be minus 1 minus root 7 over 4, because that's a negative number. But K2, which is half the side length of the square, is root 7 minus 1 over 4. And as you can already see, K2 is half the length of a side in A, So in order to find the area of A, it is squared and then multiplied by 4. So we do 4 times root 7 minus 1 over 4 squared. And we do so to get 4 times root 7 minus 1 squared over 4 squared, which is 16. 4 divided by 16 is 1/4. So 1/4 is multiplied by the root 7 minus 1 squared. Root 7 minus 1 squared, as if you know how to expand, is root 7 squared minus 2 root 7 plus 1. Root 7 squared is 7, plus 1 is 8, minus 2 root 7 is, as you can already see, 8 minus 2 root 7, and that is divided by 4. We then apply that to get 8 over 4 minus 2 root 7 over 4 to get 2 minus root 7 times 2 over 4, which is 1/2, to get 2 minus root 7 over 2 units squared. Thank you for coming to my lecture.